Very good afternoon, ladies and gentlemen. Thanks, Jose, for the introduction. I'm being humbled. Post-lunch, it is challenging, and more so because Vamsi has spelled out almost all the technical aspects of surveillance in real-time analytics. So I will kind of restrict myself to the physical security domain, other than the cyber, info, operational, being physical my core domain. And a disclaimer before everything else, these are my personal views, nothing related with my organization. So with the kind of, expansion of physical security domain with the AI-enabled, resources we have, it is tremendously challenging, especially in a very complex, diverse, and you would say different kind of environment, ecosystem, and assets. And it is humanly just not possible to do it without either AI-enabled, AI intelligence, AI augmented, or whatever you may so call. And with this onset of machine learning, deep learning, and all those kind of stuff. In the next 20 minutes or so, in the interest of time, I'll kind of dwell upon the basics, not the technical part of it, and try to connect the dots. With that, I come to the preview for the ease of assimilation and understanding. First, the challenge, especially when the physical security is scaling up, replicating, or expanding, as I already spoke about. And where AI would be used when you require that kind of detection and also verification of the detection so as to create a response that would lead to the operational efficiency. And one step ahead of that, the predictive analysis, which Vamsi spoke about and my previous speakers, which will kind of give the prophylactic security and touch upon a couple of impact on the real world case studies, just the learnings only, and how does it look like for us in the physical security, and finally, in a nutshell, how we sum up those things. So with this one, many challenges are there when we scale up. Most of them have been brought about technically also. Just to kind of cover again, one of the data overload with the kind of inputs, ingesting from different sensors, cameras, your access control, and whatnot you have. It is humongous in real time, exabytes of data and all those. So that is one challenge. Second, obviously, is the human limitation. You cannot, kind of filter, track, verify, and eventually, it leads to a false alarm and diminished your responses, and finally, the outcome would be a negative event. And the third challenge would be the complex environment. It can be a multi-faceted environment wherein you have mixed retails, commercials, you may have industry, you may have a government establishment, and many more. So when you have such kind of distributed assets, at a large scale, and those inputs coming to you at the security operations center, it becomes very, very difficult for us to carry out that real-time surveillance, verify those things, and then act upon it accordingly to, kind of negate that event. And yes, it is always linked with the ROI. When you have human-intensive, resources and the operations going up, the cost would be obviously rising. So these are a few challenges. So all the more we need AI. So this is where, like in the basis of physical security sequence, you have your, the deterrence, then you have the detection, then you have the delay, denial, respond, and then monitor, then you have the evidence, then this goes into loop again. What is most critical is that detection part of it, and verification of that detection. And especially with those, humongous amount of data. For that, you require, instruments from AI, like your computer vision, which many of my speakers have already brought about. It basically brings out the anomalies with real-time identification. Basically, it has got, in the input, you have learned data, predicts, analyze the data with the ones which is coming, and then it gives an output, and you say, okay, this is yes or this is no. I mean, how you have to respond to it. So in that, you have the object recognition, wherein it distinguishes different elements like your human, vehicle, animal, and your motion, and many other things, which would, by using the object recognition software or the process, it will increase the accuracy by almost about 99% as per the studies. Then you have facial recognition, which would reduce our tailgating, which would reduce our, access control system, and many other things, your access, your authorization, and many other things which is related with the control. And one thing which is also being done here is a noise reduction. When you have so much of data coming in from all these sensors, cameras, and equipments, so much of them in real time, a lot of noise is there which has to be reduced to only pick up those signals which are relevant to the to the operation center. So that noise reduction also is being done with the help of AI. In continuation of that, when you have the detection, the verification, you want to respond appropriately, right? And it becomes all the more challenging, as I said, with those kind of data coming to you in the operation center or the GSOC. So in this, I am just giving out an example of an intelligent alert triage. Here you see all the sensors, cameras, your other equipments giving the inputs. Then those are being filtered out using the already pre-fed data, which is in the corpus of the machine learning or the AI system, detects and then contextualize them into different contexts. And as per the context, you automate them to actions. Maybe opening a door, you're sounding an alarm, or floodlight, or calling the police, or whatever you might want to do it. So in this, you have seamless integration with your vehicle, your visitor management system, your parking management system, your personal access barrier, your intrusion detection system, smart alarms, and many other IoT devices which you would like to integrate. So, which would finally lead to the enhanced operational efficiency of the entire ecosystem. One step ahead, we, in fact, Vamsi also spoke about the predictive analysis. See, we always say prevention is better than cure. So it cuts your cost also, and it saves a lot of resources. So AI, machine learning, deep learning would, kind of give you such advantage of analyzing behavior, wherein patterns as loitering, crowd monitoring, or any kind of geofencing, or some unidentified object, or some suspicious activity, those can be kind of picked up, analyzed, predict, and then take actions accordingly using the appropriate software and the hardware. We also spoke about this predictive maintenance, wherein when you have all these systems in a large, complex environment, this system needs to be healthy. They need to function and give you the right input at all times. It cannot fail you. So the sensors which is inbuilt in all the systems would give you a real-time health status of the equipment or the sensor or the cameras, which will allow you to carry out predictive maintenance or some kind of routine maintenance, which will save a lot of cost center. And then we spoke about the anomaly detection, which is detecting what is different from the baseline which you're fit into. Okay, this is normal and this is not normal. So whatever inputs it's coming to you, it differentiates and tell you, what is not normal. And as per that, you carry out the action. Again, threat forecasting. You're using the historical data, like I'll speak about the National Crime Records Bureau. They have got a huge corpus of data wherein, okay, this is the cause and this is the effect. So the cause and effect matrix is being fed into the system, and then, it uses that thing to receive the input, analyze them, and predict, okay, this might happen. I mean, this kind of crime can happen in so and so, location or so and so place and time, and so that gives you the kind of threat forecasting, which is very important, and then proactive actions can be taken accordingly. Am I on time? Yeah, I'll take 5 more minutes. Many case studies are there, you can Google it up, and a couple of them which I picked up just for kind of showcasing how impactful it is. Like the Homeland Security of US, they have this Transport Security Administration, wherein they have the AI scanners and many other gadgets which cuts down the false alarm by about 70%, increasing the operational efficiency by about 15%. And in most of the Google campuses, you have so many AI monitored cameras, your drones, your robots, which are AI enabled, and kind of gives the security effectiveness of the perimeter by, increases the efficiency by about 40%. That's what the case study says. And many others are there, which includes your critical infrastructure of the government, of the nuclear plant, or some military establishment, police establishment, and many others, which can, using AI, detect intrusion multiple times than what human can actually do. And in the commercial setup, you have the security and loss prevention aspect, wherein shoplifting and many other things can be really used to reduce the inventory shrinkages and many other things. So how does it look like? It is quite already there, and it is evolving as we speak. It is already integrated with the autonomous drones and patrol robots, accelerating your response time drastically, reducing the operational cost, and enhancing the efficiency in a big way. And you must have heard about a lot of recent stories during Operation Sindoor and many others, and the other applications in the commercial world as well. Next is the, with the kind of real-time data-driven insights being given by the AI, machine learning, deep learning, and the other systems, you would be having those actionable intelligence, which would improve the security strategies in a dynamic manner. Also, with the advent of swarm intelligence, predictive maintenance, Gen AI, edge computing, and quantum computing, all these driverless cars and robots, drones will, kind of evolve in a big way by leaps and bounds. I would quickly touch upon the last bullet point, that is the 3 levels of AI, where we speak about AI narrow, the AI broad, and the general AI, which the third one would actually think like a human, almost at that intellectual level, and maybe even more. That would, as they say, would be somewhere around 2050. So that's still evolving. So in a nutshell, the impacts would be transformative. We are shifting from preventive to, from reactive to proactive, intelligent, actionable operations. Then you have the improved outcomes because of the accuracy and speed, cost efficiency being brought about by the AI revolution. Then you have critical for scale. Like physical security, when you expand, replicate It is not simply possible without using such AI-enabled or IoT-enabled devices and the systems. And the last one, which I would like to mention, is about to embrace AI to build resilient, adaptive security infrastructure for the times ahead, and that also ethically and responsibly. In ethics, AI ethics itself is a domain by itself, wherein it speaks about transparency, your explainability, interpretability, privacy, and all those things, which is very, very important. With that, I will leave a thought before I wind up for today. In God we trust, all others must bring data. This is being, the phrase is being said by W. Edward Deming, a renowned management consultant and a statistician. So when you have data everywhere, how do you manage them? You can only manage them by using your artificial intelligence, machine learning, and other intelligent software and hardware devices. Thank you. That's all from my side.